Hi there, Ms. Hedgecock here again for your second video for lesson 3.4, which is about solving exponential and log equations. In this video, we're going to talk about solving log equations. Last video, we talked about exponential and the two different types of problems you're going to see. In this video, we're going to talk about log problems and the three different types you're going to see. The first, I think, tends to be the easiest. It's when you have log equals log, and there's nothing else that's being added or subtracted. So there's no like plus 3 over here. There's no another log over here. Nothing like that. It's literally just log equals log. When you have log equals log, and they're going to be the same bases, all right? If they're not the same bases, you can't do this, but we're going to give you the same bases, all right? When it's log equals log, you're going to set the arguments equal to each other. This word right here just means the insides. So this equals this. So I'm going to do 4 minus x equals 3x minus 12. Easy. Just solve, linear, all that kind of stuff. So I'm going to add x to both sides. And I am going to add 12 to both sides. So I get 16 equals 4x. Divide both sides by 4. I get x equals 4. Now, with log, you have to check your answers. With exponential, it's not as big of a deal, but for log, you have to check your answers. And that is because you can't have log and then a negative number. You're not allowed to have that in a log. It's undefined. It doesn't work. So you need to check. So for example, let's take 4 and plug it into our left side. When I plug in 4, and you have a calculator to help you do this, I get log base 2 of 0. And if I type in log base 2 of 0, I also get undefined. All right, so that's the other thing you can't have is log of 0. Because if I change this to exponential form, 2 to the x equals 0, what could x be that would give me 0? Nothing. All right, 2 to the 0 power is 1, 2 to the first power is 2, but there's nothing I could plug in for x to give me 0. So you can't have negatives in logs, and you can't have zeros in log. You get undefined for both of them. All right, so since 4 didn't work, cross it out. And since we have no other options, this one actually has no solutions. No solutions. Oops, sorry. That's what this one has. All right, so two things to remember. Logs can't be negative on the inside. Logs can't be 0 on the inside. But in general, if you have log equals log, set the insides equal to each other, solve. That's type 1. Type 2 is where you change the log to exponential form. This usually happens when you have log, where's my pen? Oh, there we go. When you have log equal number. When you have a point where it's log equals a number, last example was log equal log, when you can make it log equals a number, usually you're going to switch it to exponential form, all right? So to do that, you need to make sure your log is all by itself on one side. It needs to be just log equals just number. So what we're going to do in this example is we're going to get the log by itself. So I'm going to add 3 to both sides first. So I get 2 log base 5 x plus 2 equals 4. Okay, log is not by itself yet, so I'm going to divide both sides by 2. So I get log base 5 x plus 2 equals 2. At this point, I now have log equals number. When that happens, we're going to switch it to exponential form. So remember in the last video, strategy 2 was when you had like, this was our example, I think. You had to change it to a log to solve and then put it in your calculator. Well, we're going to switch this log to an exponential. So we're going to have to do that. Those ones are usually easier to solve for. These ones you have to use a calculator. But I'm going to switch it to exponential. So the base is going to be the same as my log. Then the 2 becomes the exponent, and then it equals x plus 2. And now I can go ahead and solve. So I have 25 equals x plus 2. I'm going to subtract 2 on both sides, and I get x equals 23. Right? I get my answer, and I still got to check. So you're going to use your calculator to help you. I'm going to plug in 23, blah, 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 do all the stuff, and yes, it should work. And if you need help checking and all that kind of stuff, you can ask. But that's the second type of problem. So type 1, log equal log, set the insides equal to each other. Type 2, log equal number, change it to exponential, right? We're now going to do type 3, the last type. Type 3 is like type 2, but you are going to have to do one extra thing, and it's combine or condense logs. So we have to rely on lesson 3.3. This is 3.3. So lesson 3.3, which is properties or laws of logs, where we expanded and condensed. We are going to have to condense logs and then switch it to exponential form. So since we eventually want to switch it to exponential form, eventually we want log equals number. So that means we want to put all the logs on one side and then all the other stuff on the other side. So that's what we're going to do. So I'm going to move my 1 to the other side, and I'm going to subtract my log. Think of it like a number or something like that. All right, so I'm going to subtract my log so I can move my logs to one side, numbers to the other side. So that cancels, that cancels. So I have log base 3 x plus 2 minus log base 3 of x equals 1. So when I have all my logs on one side equals a number, I now have to condense. All right, I need to condense, so I need to make them one log. Now, hopefully you remember your properties and laws of logs. When it says minus, you divide. So I'm going to do log base 3 x plus 2 divided by x equals 1. Right? So remember, subtraction you divide, addition you multiply. Once I do that, I now have log equals number. When I have log equals number, this is strategy 2, we now switch it to exponential. So I'm going to do same base as my log. It's raised to the first power, and then it's x plus 2 over x. And then I want to solve. So what I'm going to do is 3 to the first power is just 3. And I'm going to put it over 1 because 3 is the same thing as 3 over 1. And what I'm going to do is I'm going to cross multiply. So I'm going to do x plus 2 times 1, which is just x plus 2. I'm going to do 3 times x, which is 3x. And now I have something I can solve. So I'm going to subtract x on both sides. Boop. 2 equals 2x. Divide by 2. X equals 1. And then I'm going to have to check. So I'm going to take 1. I'm going to plug it into this problem up here. I'm going to make sure it's true and it works. When I do that, it should work in this example. So my answer is 1. All right. So those are your 3 different strategies you can use to help you. 2 and 3 are very similar. The one extra step is that you have to make all your logs into one log. So if you have multiple, make them one log and then go from there. All right. So 2 examples. I want you to go ahead, pause here, try the problems, and then when you unpause, my answers are going to be up. I'll quickly walk through them, and that will be it for this video. All right, and there are the answers to the 2 examples. For the one on the left, so the first thing you do have to deal with is the 4 in the front, and as our laws of logs say, the 4 in the front, you move it to the exponent of the argument, the thing on the inside, so it's really 2 to the 4th. And then you have 2 options. You could have, from here, you could have combined them into one log and then switched to exponential form, which would be fine, so that would be strategy 3. What I did, because I'm a little lazy, and I like to do work smarter, not harder sometimes, I added the other log to the other side, so I had log equal log, and I just set the insides equal to each other and I solved. And of course I checked, 2 does work, checked it in my calculator, good to go. The one on the right, we got ln, all right? So with an ln, I'm probably going to switch it to a exponential. So I'm going to subtract 2, then I'm going to divide by 4, And then I need to remember, ln is really log base e. So I'm going to use that to help me switch to exponential. So now it's e to the second power equals 8x minus 2. I'm going to solve for e by adding 2 and then dividing by 8. And then in exact form, you can leave it as e squared plus 2 over 8. That's a great way to leave your answer. If I asked for you to round, it's about 1.17, all right? But leaving it like this, done. Good, beautiful. I will give you a hint, warning, I don't know what you want to call it. When you do some of these problems, especially for log, you might get problems where you have to factor. Just as a heads up, you know, because we're going to get some problems where this right here is a plus, this over here is a number, and you're going to have to factor. So just keep that in mind, which means you're going to get two answers, and they both could work. One could work, none could work. It's going to be a little all over the place, all right? But just keep that in mind. If you get a factoring problem, that's okay, because you can factor in these types of problems. All right, so that's it for lesson 3.4. So what you're going to do is I recommend you practice with the solving exponential and log equations delta math. Just try some of the problems. Again, you don't have to do the whole delta math. Try if you get comfortable. If you want to do problems with me, I'll do problems with me or your respective teacher. And then you're going to complete the lesson 3.4 master check, which is also going to be in Schoology. And it's going to be 2 questions, 1 log, 1 exponential. So make sure you understand both of them. All right, that's it.